Alright, so we've been looking at inverse functions. Now we want to hone in and look at derivatives. How are the derivatives of these inverse functions related to each other? Okay? So, first of all, let's just think about this here. If I have, and let's not just do this by plugging in. Let's actually think a little bit here, okay? If I have g prime of 1, okay, g prime of x would be 2x, right? And f prime of x is going to equal 1/2 times x minus 4 to the negative 1/2, right? So let's go ahead and figure out some of these, okay? G prime of 1. Come on, guys, wake up. This is the easy part. That's 2. What's g of 1? 5. What's f prime of g of 1? So in other words, f prime of 5.
1.
We have 1/2 times the square root of 1, right?
Oh, yeah.
1 over the square root of 1. So that's 1/2. Just to be proper here. 1 over square root of 1. Okay? What's 1 over f prime of g of 1? Yeah, it's 2. We just found f prime of g of 1, so that's going to be 2. Alright? So now, let's think through this here. Is there any connection that you can make?
Why there are so many things related to 2?
So many things are related to 2?
Yes.
Well, let's look at the 2's. Where do we see 2's show up? Yeah. What about this? You notice those end up being the same? Okay. So what do you think might be true? I mean, we see here g prime of 1.
So it's like g prime of x equals f prime of g of x? Wait.
1 over that thing.
Oh, 1 over? Oh,
1 over f prime of g of x. Think so? And it works here, right? It works here. This is 1 over f prime of g of 1. Okay? You want to try a different number and see if it still works? Let's see. Let's say we did g prime of negative 2. Okay? Oh wait, x greater than 0. Let's not do negative 2. There we go. G prime of 2. Okay, well g prime is 2x. So that's going to be 2 times 2, which is 4. Okay? Let's try 1 over f prime of g of 2. What's g of 2? 8. Okay, so we have f prime of 8. What's f prime of 8? 1/2 of 8 minus 4 to the negative 1/2 power. So hey, that's going to push the 2 up top and the 4 to the 1/2 up top. So now it's a positive 1/2 power. So that's 2 times 2, which equals 4. Okay? So, what would have to be true? Is this going to work for any two functions? Okay, we're talking about inverse functions, alright? So we're talking about inverse functions. The derivative of an inverse function, if you scroll down the page, the derivative of an inverse function does actually work like we just saw, okay? Let f be a function that is differentiable on an interval I. If f has an inverse function g, then number one, g is differentiable at any x where f prime of g of x does not equal 0. Okay? And g prime of x will equal 1 over f prime of g of x. Again, so long as f prime of g of x does not equal 0. Okay? Because obviously we can't do 1 over 0. Okay? So, that is our theorem for this section. If we have inverse functions, okay, then the derivative of one is 1 over the derivative of the function of the other, okay? So let's look real quickly here at a quick proof of this, okay? A quick proof of this. Let's take the equation based on our definition of inverse functions. I know that f of g of x will equal x, right? So if I take the derivative of x, I get 1. Right? And if I take the derivative of the other side, that is going to be f prime of g of x. And then I have to use the chain rule. Times g prime of x. Well, as long as f prime of g of x does not equal 0, I can divide by that on both sides. So if I divide both sides, I get 1 over f prime of g of x. Okay? Where f prime of g of x does not equal 0. Okay? So we just proved it. Okay? We just proved it. Now, what other properties do we have here? Okay? There's a couple of other properties here. First of all, if f is a function whose domain is in an interval, and if f has an inverse function, the following statements are true, okay? If f is continuous on the domain, then the inverse will also be continuous on the domain. Okay? If f is increasing on its domain, then the inverse will also increase on the domain. If f is decreasing on the domain, then f inverse will also decrease on the domain. And finally, if f is differentiable on an interval containing c and f prime of c is not 0, then the inverse is differentiable at f of c. Okay, and basically that is just stating the case that we saw there in our theorem. As long as the derivative of at a value, f prime of that value doesn't equal 0, then g prime will exist. Okay? And it not only exists, but it equals 1 over f prime of g of x. Or 1 over f prime of g of c in this case. Okay? So that's the basic theorem here. Let's take a look at using it a little bit. Here's the restatement of the theorem. Okay? So let's think about this here. What is the value of the inverse when x equals 3? Okay? What's the value of the inverse? And then what's the value of the derivative of the inverse when x equals 3? So notice here we have the inverse notation and the prime. You got to be careful with your notation here, especially those of you who tend to be sloppy writers. Okay? Okay? So what's the value of f inverse when x equals 3? How are we starting here?
We're not having a deep considering.
You're considering it deeply, huh? Well, let's think. How do we find an inverse? We swap x and y, right?
Yes.
Yeah.
Okay.
Do that.
So let's do this. We're going to make it x equals 1/4 f inverse cubed plus f inverse minus 1, right? So if I make x equal 3, then let's see what we can do here. We have a if x is 3, all right, I'm going to add 1 to both sides, and that's 1/4 times f inverse cubed plus f inverse. Okay? How about if I multiply by 4? So that's going to be 16 equals f inverse cubed plus 4 times f inverse.
But before is always for cubit, right?
Hmm?
Or just, like, when you times 4, you times, oh, yeah, yeah.
Okay.
Do we need to, oh yes, we are getting the middle line.
We're going to solve, yeah, we need to solve for what the inverse
Will it help
equals.
to subtract the f inverse power 3?
Well, let's think this through here. We have, if I factor out an f inverse, I'm going to have an f inverse
Squared
squared
plus 4.
plus 4. That equals 16.
Divide both sides by f inverse squared plus 4. Don't do that.
I don't want to do that. Because it's not equal to 0. Okay. So I get to do 0 equals f inverse cubed plus 4 times f inverse minus 16.
Or it is minus 16, right?
Alright, so now we have to solve for what would make that equal to 0. Okay. No, because that's cubed and that's the first
I
power.
know the answer.
What?
It is 2.
It's 2.
Yeah.
2 cubed plus 4 times 2.
Actually, wasn't lying. Actually, it's 2.
Okay. It does work.
I know.
Okay. So that means f inverse of 3 is 2.
Okay, yeah, but how do you find it?
How do you find it?
It says
You could
something.
use, you could use the rational zero test at this point. Look at the factors of 16 and do synthetic division. Okay, in fact, if I did that, I would have f inverse minus 2 times f inverse squared. Let's see, if I have a 1, 0, 4, negative 16, and I'm going by 2, I'd have a 1, 2, 2, 4, 8, 16, 0, so that would be squared plus 2 times f inverse plus 8. If I factored it out,
Can I ask you a question?
okay.
So why don't you just write f sub the -1 to y? Because I think y.
You could. That might make life easier as far as you're showing your work.
Well, that makes the thing seems more simple.
Okay. Yeah, you can do that for sure. If I'm trying to find the inverse and I just switched the x and y and I had gotten down to that, I'd just be writing y's instead of f inverses. If you guys want to do that, we can do that. There. Does that make you feel better?
Oh, much better.
Yeah, so much better.
Okay? So, y. You guys are
some of
asking this a lot.
There were f inverses, so you kind of erased them, so we don't know where f inverse is now.
Well, all the y's are f inverse.
Okay.
So, now, you also notice that y squared plus 2y plus 8, if you tried to solve that, where that equaled 0, you'd get complex numbers. So 2 is the only real number solution, which is why this is an inverse. Okay? It's why this is an inverse there. Okay? So, y has to equal 2, which means f inverse of 3 has to equal 2 is our only solution. Okay? So now, what is the derivative of the inverse of f at 3? Okay? Well, it's 1 over, that's going to be 1 over f prime of f inverse of 3. This is why we had to figure out what f inverse of 3 was. Okay? So that's going to be 1 over f prime of 2. Well, what's f prime of 2? Well, let's come back up here. F prime of x is 3/4 x squared plus 1. So f prime of 2 is going to be 3/4 times 4 plus 1. So 3 plus 1 equals 4. Okay? 3/4 times 4 plus 1 is 1 over 4. So the derivative of the inverse at 3 equals 1/4. Okay? So notice here, I actually don't even have to necessarily find the equation of the inverse. I don't necessarily have to find the derivative of the inverse. I can simply use the property here. Okay? Does that make sense? All right. Okay, so let's really quickly look at example 2 here. Whoops. All right. So we want to show the slopes of the graphs of f and f inverse are reciprocals at each of the following points. So the slopes of the graphs you're automatically thinking? Derivative. Okay. So what is f prime? 2x. There we go. And f inverse prime.
You didn't write the x, and you wrote it as f to -1 instead of
F inverse prime. Yeah, that's what it's supposed to be.
Boom.
F inverse prime is 1/2 x to -1/2, right? So let's actually look at the slopes. So the slope of f of x at the point 2, 4, so 2, 4, the slope of f of x, f prime of 2, is 4, okay? Now, if I look at the other point, 4, 2, f inverse prime of 4 is 1/2 times 4 to the negative 1/2. Well, that's 1/2 times 1 over the square root of 4, which is 2. Okay, so that's 1/4. And obviously 4 and 1/4 are reciprocals of each other. Okay. If I were to look at part B here, f prime of 3 is 2 times 3, which is 6. Okay. F inverse prime of 3 is 1 over 2 times 3 to the negative 1/2. So that is, or I'm sorry, I plugged in the wrong one. I used the other point here. F inverse prime of 9, that's going to be 1/2 times 9 to the negative 1/2 power, which is 1/2 times 1/3, which of course is 1/6. And that's the reciprocal there. If you look at the graph, you can actually see this down here at the bottom. At 3, 9, the slope is 6 on x squared. At 9, 3, the inverse, the slope is 1/6 on the square root of x. Okay, and from the first one at the point 2, 4 on f of x, our slope is 4. At the point 4, 2 on the inverse, the slope is 1/4. Okay, so there you can see the relationship that we have, and that does back up the relationship that we saw earlier, that g prime of x, remember g is the inverse, is 1 over f prime of g of x. Okay, so if let's say we took that point 4, 2, the inverse evaluated at 4 is 2, so that's 1 over f prime of g of 4, which is 1 over f prime of 2. F prime of 2, we already saw, was 4, so this is 1 over 4, and that is what we got when we did f inverse prime of 4. Okay?